Hello students, I am Dilip Pudani, Assistant Professor at LJ Institute of Engineering and Technology. In partial derivatives, today I will teach you total derivatives. So in total derivatives, we will discuss how to find out the derivative of composite function of one and more than one variable. So let's start. If u equals to function of xy, where x that is equals to function of t, y is also function of t, then u is a function of t and is called the composite function of a single variable t. So in this diagram you can see that u is a function of x and y, and x and y are functions of single variable t. So we can say that u is a composite function of single variable t. So in this case, we will understand how to find out derivative of u with respect to t. So du by dt, that is, you can see from first part, that is u from x and x from t. So u is a function of two variables, x and y. So first of all, we will write down partial derivative of u with respect to x. So that is del u by del x. And then after x is a function of t and x is a function of single variable t. So we will write down ordinary derivative, that is dx by dt. Plus for second path, u is from y and y is from t. So u is a function of two variables, x and y. So we will write down del u by del y. And y is a function of single variable t, so we will write down ordinary derivative, that is dy by dt. So we have du by dt, that is equals to del u by del x into dx by dt plus del u by del y into dy by dt. So this is called total derivative of u. Now similarly, if u equals to function of x, y, z, where x, y and z are functions of single variable t, then u is a function of t and is called the composite function of single variable t. So from the diagram you can see that u is a function of three variables, x, y and z, and x, y and z are functions of single variable t. So in this case, du by dt, that will be del u by del x into dx by dt plus del u by del y into dy by dt plus del u by del z into dz by dt. So this is again total derivative of u. But here u is a function of three variables, x, y and z, and x, y, z are functions of single variable t. Now example 1 related to this topic, we have to find out dw by dt if w equals to xy plus z and x equals to cos t, y equals to sin t and z equals to t. So first of all, here w equals to xy plus z. We have to find out dw by dt. So dw by dt, that will be del w by del x into dx by dt plus del w by del y into dy by dt plus del w by del z into dz by dt. So first of all, we will find out del w by del x. Del w by del x means partial derivative of w with respect to x. So for the first term xy, y is constant and derivative of x is 1. And for the second term z, it is constant, so its derivative will be 0. So we have del w by del x, that is equals to y. Now similarly, we will find out del w by del y, and this is partial derivative of w with respect to y. So we will keep x and z constant. So for the first term xy, partial derivative of xy with respect to y. So x is constant and derivative of y is 1, and derivative of z will be 0. Now we will find out del w by del z, and del w by del z means partial derivative of w with respect to z, so we have to keep x and y constant. So derivative of xy will be 0 and derivative of z is 1. Now we will find out dx by dt, dy by dt and dz by dt. So x equals to cos t, So dx by dt equals to derivative of cos t, and derivative of cos t is minus sin t. Then after dy by dt, so y is sin t, so derivative of sin t is cos t. Then after z is t, so derivative of z with respect to t, that is dz by dt, the result is 1. Now we will find out dw by dt, that is del w by del x into dx by dt plus del w by del y into dy by dt plus del w by del z into dz by dt. And del w by del x is y, dx by dt is minus sin t, plus del w by del y is x, dy by dt is cos t, del w by del z, that is 1, and dz by dt, that is also 1. But we have to find out dw by dt in terms of t. So we will replace y by sin t and x by cos t. So replacing y by sin t, minus sin t is same, plus replacing x by cos t is same, and plus 1. So sin t into minus sin t, the result is minus sin square t. Then after plus cos t into cos t, the result is cos square t plus 1. Now we know that 1 minus sin square t, result is cos square t, and cos square t will be as it is. So cos square t plus cos square t, answer is 2 cos square t. So this is dw by dt. Now here we will see the composite function of two variables. If z equals to function of xy, where x is a function of uv, y is a function of uv, then z is a function of uv, and this is called composite function of two variables u and v. So from the diagram you can see that z is a function of two variables x and y, and x and y are functions of uv. So indirectly we have z is a function of uv, and this is a composite function of two variables u and v. So in this case we are in a position to find out del z by del u. Why del z by del u? Because here z is a composite function of two variables. One is u and other is v. So we can find out del z by del u and del z by del v. So first of all, del z by del u. So now you can see path from z to x and from x to uv. So first of all, del z by del u, that will be del z by del x into del x by del u. Then after, for the second part, from z to y and from y to uv. So we have del z by del y into del y by del u. Now similarly we can find out del z by del v. So that will be del z by del x into del x by del v plus del z by del y into del y by del v. Okay, now we will see example related to this topic. We have to find out del w by del r and del w by del s in terms of r and s if w equals to x plus 2y plus z square, where x equals to r by s, y equals to r square plus log x, and z equals to 2r. So first of all, here w is given to us, and that is function of three variables x plus 2y plus z square. So first of all, we will find out del w by del r. Here you can see that w is a function of three variables x, y, and z, and x, y, and z are functions of r and s. So first of all, we will write down del w by del r. So that is equals to del w by del x into del x by del r plus del w by del y into del y by del r plus del w by del z into del z by del r. So first of all, we will find out del w by del x. So w equals to x plus 2y plus z square. Now we will differentiate w partially with respect to x, and derivative of x with respect to x, answer is 1. 2y and z square are constant, so its derivative will be 0. Now we will find out del x by del r. Now you can see that x equals to r upon x. So partial derivative of x with respect to r. So derivative of r is 1 and s is constant. So we have del x by del r, that is equals to 1 upon s. Now we will find out del w by del y. So w equals to x plus 2y plus z square. Now we will differentiate partially w with respect to y. So x and z square will be constant, so its derivative will be 0. 2 is constant and derivative of y is 1, so the result is 2. Now we will find out del y by del r. Now you can see that y equals to r square plus log s, and we are differentiating y partially with respect to r. So derivative of r square, answer is 2r, and log s is constant, so its derivative will be 0. Now del w by del z. Del w by del z, it means partial derivative of w with respect to z, so we will keep x and 2y constant and its derivative will be 0. And then after derivative of z square, answer is 2z. Now we have to find out del z by del r. Now as you can see that z equals to 2r. So partial derivative of z with respect to r, answer is 2, and derivative of r is 1. So 2 into 1, answer is 2. Now this is del w by del r. Now we will simplify this result. 1 into 1 upon s, that is 1 upon s. 2 into 2r, that is 4r. Then after 2z into 2, that is 4z. Now 1 upon s will be as it is, 4r will be as it is, and replacing z by 2r. So 4 into 2r, result is 8r, and 8r plus 4r, the result is 12r, and 1 upon s will be as it is. So we have del w by del r, that is equals to 1 upon s plus 12r. Now we will find out del w by del s. So according to the formula, del w by del s, that is equals to del w by del x into del x by del s plus del w by del y into del y by del s plus del w by del z into del z by del s. Now we have found del w by del x, del w by del y, and del w by del z. So you can see del w by del x is 1. Then after del w by del y is 2, and del w by del z, that is 2z. Now we have to find out del x by del s, del y by del s, and del z by del s. So x equals to r upon s. So del x by del s. Okay. So r will be constant, and derivative of 1 upon s, answer is minus 1 upon s square. So we have del x by del s, that is equals to minus 1 upon s square. Then after for del y by del s, y equals to r square plus log x. So r square is constant and its derivative will be 0. And derivative of log s is 1 upon s. Now we will find out del z by del s, and z equals to 2r. So 2r will be constant, so its derivative will be 0. And if we will multiply 2z by 0, the result is 0. And the simplification is minus r upon s square plus 2 upon s. So this is del w by del s. Now we will see example 3 related to this topic. If u equals to function of x by y, comma y by z, comma z by x, then we have to prove that x del u by del x plus y del u by del y plus z del u by del z, that is equals to 0. So here, suppose x upon y equals to L, y upon z equals to m, and z upon x equals to n. So we will be having u equals to function of L, m, and n. And indirectly, L, m, and n are functions of x, y, z. So u is a composite function of 3 variables x, y, and z. So we are in a position to find out del u by del x, del u by del y, and del u by del z. So from the diagram you can see that u is a function of lmn, and lmn are functions of x, y, z. So first of all, we will find out del u by del x. So you can observe that u is a function of lmn, and lmn are functions of x, y, z. So we have del u by del x, that is equals to del u by del l into del l by del x plus del u by del m into del m by del x plus del u by del n into del n by del x. Here u equals to f of l comma m comma n. So we cannot find out del u by del l, del u by del m, and del u by del n. So these partial derivative will be as it is, and we have to find out del l by del x, del m by del x, and del n by del x. So you can see that del u by del l, that will be as it is. Now we have to find out del l by del x, and l is x upon y. So del l by del x, derivative of x is 1 and y is constant. So del l by del x is 1 upon y. Then after del u by del m, and m equals to y by z. del m by del x, that will be 0 because m is a function of y and z. Then after del u by del n into del n by del x, and n equals to z upon x. So z is constant and derivative of 1 upon x answer is minus 1 upon x square. So we have del n by del x, that is minus z upon x square. Now we will multiply this result by x to find out x into del u by del x. So we have x into del u by del x, that is equals to multiplying del u by del n into 1 upon y by x. So it is x upon y into del u by del n. Then after multiplying del u by del n into minus z over x square by x, so it is minus z over x into del u by del n. Now say this is result number 1. Now similarly we will find out del u by del y. So according to the formula, it is del u by del n into del l by del y plus del u by del m into del m by del y plus del u by del n into del n by del y. So del u by del l, del u by del m and del u by del n, that will be as it is. So del u by del l will be as it is. Now we have to find out del l by del y. So that is partial derivative of l with respect to y. L equals to x upon y. X is constant and derivative of 1 upon y, answer is minus 1 upon y square. So del L by del y is minus x upon y square. Then after del u by del m will be as it is. Now del m by del y, n equals to y upon z. So derivative of y is 1 and z is constant. So we have del m by del y, that is equals to 1 upon z. Then after del u by del n will be as it is and n equals to z by x. So z by x, that is a function of z and x, so del n by del y will be 0. Now multiplying this result by y, so we have y del u by del y, that is equals to minus x upon y into del u by del n plus y upon z into del u by del m. Now say this is result number 2. Now similarly we will find out del u by del z, that is equals to del u by del n into del l by del z plus del u by del m into del m by del z plus del u by del n into del n by del z. So del u by del l, that will be as it is, and l equals to x upon y, and that is a function of x and y, and partial derivative of l with respect to z, that will be 0. Then after del u by del m, that will be as it is. Now del m by del z, m equals to y upon z, so y is constant and derivative of 1 upon z, answer is minus 1 upon z square. Then after del u by del n, that will be as it is. Now del n by del z, and n equals to z upon x, so derivative of z is 1 and x is constant, so del n by del z is 1 upon x. Now multiplying this result by z, so we have z del u by del z, that is equals to multiplying del u by del m into minus y over z square by z, so it will become minus y over z into del u by del m, and finally multiplying the last term, that is del u by del n into 1 upon x by z, so the result is z upon x into del u by del n. Now say this is result number 3. Now we will add result number 1, 2 and 3. So in the left hand side we will be having x del u by del x plus y del u by del y plus z del u by del z. And in the right hand side we will be having total 6 terms, and if you will make a pair of 2, then 2 terms will be like terms, one will be having positive sign and other will be having negative sign. So the total result, that will be 0. So we have x del u by del x plus y del u by del y plus z del u by del z, that is equals to 0. So in this lecture we have discussed the concept of total derivative, how to find out derivative of composite function of one and more than one variable, examples related to this topic. Thank you for watching this video. I will see you in the next lecture.